Grade 7s, today we'll be talking about prime and composite numbers. So what are prime and composite numbers? Let us start by knowing the definition, by writing down the definition of a prime number. So a prime number, so prime numbers, prime numbers are natural numbers that has have exactly two factors. They have exactly two factors. Okay, and the two factors are 1 and itself. There are exactly two factors, 1 and itself. Okay, actually it should be two different factors, different factors, 1 and itself. They have to be different. Okay, and so if we think about it, what are some examples of prime numbers? 2 is a prime number. We always start with 2 is a prime number because 2 has exactly two factors. What can divide 2 evenly? Well, 1 divide 2, um, the answer is 2. 2 can divide 2 and the answer is 1. And so 2 has exactly two factors, and so 2 is a prime number. So i.e., we have 2 is a prime number. 3 is also a prime number because there are no other factors other than 1 and itself. What are some other prime numbers? Is 4 a prime number? No, because 4 can be divided by 2. And it can be divided by 1, 2, and 4. And so 4 is not a prime number. Is 5 a prime number? Yes, 5 is a prime number because it can only be divided by 1 and 5. And so there's 2, there's 3, there's 5, and then there's 7, and so on. Is 9 a prime number? No, because 9 can be divided by 3. So as you can see, not all odd numbers are prime numbers, and at the same time, other than two, all the other even numbers are non-prime numbers. And so the other type of number we're going to talk about is called composite numbers. Okay, composite numbers. And so composite numbers are natural numbers that natural numbers that have more than two factors. This is the actual definition of a composite number. Now, is it safe to say that, oh, composite numbers are all the non-prime numbers? Well, you are almost correct, but 1 is not a composite number. 1 is also not a prime number. And so that's why you cannot say that composite numbers are non-prime numbers because there is the exception of 1 over there. And so the better definition of what is a composite number, it is numbers that has more than two factors. So for example, if I bring in 4, the factors of 4 are 1, 2, and 4. That is 3 factors. And so there's more than 2. Another example, if we have 6, we have 1, 2, 3, and 6. There are 4 factors. And so it has more than 2 factors. And so what about the next odd number? Okay, what is an odd number that is not a prime number? And so 9 is an odd number. It is also a composite number. And so the factors are 1, 3, and 9. And so 9 is a composite number because it has 3 factors, more than 2. So these are prime numbers and these are composite numbers. And so what about that special number 1? Okay, so what about 1? What about 1? What happens to 1? 1 is neither a prime number nor a composite number because if we think about the definition of a prime number, it has to be two different factors. And so 1 is only made out of 1 times 1, and 1 is equal to 1 times 1. And they are the same. They are the same factor, which means that 1 only has one factor. which means that it is not a prime number. It doesn't fit into the definition of a prime number, nor a composite number, because composite numbers need to have more than two factors, and one only has one. Okay, and so one is neither prime nor composite. So let's move on to the next thing. So now that we know what a prime number is, let's move on to something called prime factorization. Prime factorization. And so any composite number can be written in a special form called prime factor. Okay, so we can write as a product. Okay, any composite number can be written as a product of its prime factors. What do I mean by prime factors? As a product of its prime factors. So let's think of the number 6. Okay, let's think of the number 6 over here. 6 is equal to, I can write 6 as a product of its prime factors. And so 6 is equal to 2 times 3. 2 is a prime number. 3 is also a prime number. Okay, which means that we can no longer split those factors into its smaller parts. And so if we think of another number, let's say, let's think of 12 as another example. So 12, can we write 12 as a product of its prime factors? And so what is the way that we can split up 12 into a product of its prime factors? I know that 12 is equal to 2 times 6. And from our previous example, 6 is equal to 2 times 3, which means that I can write this as equal to 2 times 3. Now, 6 is not yet a prime number, not a prime, which means that 2 times 6 is not a product of its prime factors because 6 is not prime. We can further split. So not prime, so can further split 6 into its prime factors. So how do we write a bigger number as a product of its prime factor? How do we write a big number? So let's do a number, example 1. So let's do an example. So example 1, we want to writing um, composite numbers as a product of its prime factors. Okay, so this is the first example, okay? And we want to write the number 180 as a product of its prime factors. And so we're going to use, now remember last lesson we learned factor tree. We are going to continue using the factor tree method. And so what we're going to do is we're going to write 180 right in the middle over here. And then I'm going to actually use the smallest available prime number to divide. Okay, the smallest factor that is not 1 that can divide 180. And we always try to use 2 if it is available. And so I can split it into 2 times 90. And then 90 can be split into 2 times 45. 45 can be split into 3 times 15. And lastly, 15 can be split into 3 times 5. And so here are all its prime factors. So all the prime factors are these over here. And so when we write out the number again, we write the number as 180 is equal to, count the number of 2s. That's 2 times 2, and then times 3 times 3, and times 5 in the end. So this is how we write our number, our composite number, as a product of its prime factors. Now, we're not done over here. We're almost done. Now, the last step is, you see that there are multiple 2's over here. So there are 2 times 2, And then there's also 3 times 3. Now we learned index form before, which means that if there are numbers that multiply by itself, we can combine them. We can change that into index form. So this is 2 squared times 3 squared times 5 in the end. Now let's do one more example. I'm going to take this example from the textbook, from exercise 4D, and I'm going to do question 6F as an example, okay? So I'm going to do 6F over here. So first of all, what you need to do is you need to write down the number. So the number I'm going to use is 88. Okay, so then what you need to do is you need to split it using the factor tree. So I can divide this by 2. Okay, I'm going to draw smaller lines. And so that's 2 times 44. And then there's 2 times 22. And then lastly, this is 2 times 11. Can 11 be split anymore? No, because it is a prime number. And so lastly, we write down 88 is equal to 2 times 2 times 2 times 11, and then that is equal to 2 cubed because there are 3 2's times 11, and then we are done with the question. Okay, so your homework today is to do exercise 4D questions 1 A, B, C, 6 A, C, D, E, and question 8. So once you've finished your homework, please upload your work onto OneNote. Okay, I will see you guys next lesson.